Yeah, so today we'll talk about data modeling across the data lifecycle. This is actually a new talk, a new twist on a talk I've been giving around the world called Data Modeling is Dead, Long Live Data Modeling. Who's caught that talk online before? Exactly 1, 2 people, great. 4, okay, so that's great. Who likes data modeling? I guess you can't say, but you're in good hands right now if you answer this question. Who hates data modeling? Yeah, me too, I'm just kidding. So who am I? Yeah, I wrote a book, got really popular, I guess. So, recovering data scientist. I still work as a data engineer and an architect, but I increasingly spend my time traveling the globe every couple weeks now, talking to audiences such as yourself about data modeling and data engineering and other stuff, rock climbing, if you want to talk about that. Yeah. And motivations for this talk, and why do I talk about data modeling now? I should be out there talking about data engineering and pumping up my book, and but which I should do actually, but but I felt like after I wrote the book, the topic of data modeling still loomed really big in my head. I couldn't escape it. Meanwhile, I got a lot of questions from people about why I didn't cover this or that in data modeling. It turns out data modelers are very pedantic and very particular and nitpicky. So, and also, yeah, Nico's nodding his head in agreement. He's one of them. So, yeah, so along the way, I was like, okay, so I think that the topic of data modeling deserves, I think, a second look right now. In my opinion, in my observations, it feels like data modeling has died a very slow and gradual then sudden death, if you know what I mean. It's the old saying that, how did you go poor? Well, gradually and very quickly. And this is what happened to data modeling. We can talk more about why this is, but I keep seeing data teams ignore data modeling, and they create huge and expensive problems for themselves. Who's seen this, by the way? Half the people. Okay, you don't need to raise your hand if you want to stay quiet. Silent majority, I see. Yeah, so I think if we continue to ignore data modeling, we're in for a whole host of problems. And why this talk now? Why didn't I give this talk back in like 1984 or something when people were still data modeling? Well, one, I was a kid. 2, it feels like data modeling has become a lost art, which I talked about. We have lots of fancy tools. I don't think we have a shortage of tools at this point. But I still feel like there's a huge education gap, right? A huge knowledge gaps in terms of how to use the tools that we have. Data sets I see are overwhelmingly a mess. So I do still run a consultancy, and the data sets they're terrible these days. They used to be better. So, and that's not me being an old man cranky about data sets, although maybe I am. Who does AI or wants to do AI? Whose company wants to do AI? That's like the smallest number of companies I've seen. That's interesting. Well, elsewhere in the world, AI is getting really popular. It'll catch up at some point. It might happen. Yeah, so AI is getting a fresh look, and what this means is if you come to your CEO and say, I want to do AI, they'll open up their pocketbook for you. They'll give you any amount of money you want, right? So you should do this. It's actually pretty fun. Even if you have no use case for it whatsoever, which is like most companies, you just say AI, and they'll be like, how much do you want? Like, I didn't even tell you what I'm doing. Well, it doesn't matter. That's what we are, right? But now the question is, if we're going to start doing AI seriously, when are we going to start taking the practices of data governance, management, all the stuff we've been whining about for decades? Like, when are we going to get the data right? When are we going to start adding value to the business, right? This is a time. The money's there, the attention's there. Who watched OpenAI's Dev Days, by the way? That was this week. Like a grand total of like my friends. That's cool. No, but there's a lot of cool stuff happening in AI right now. It's ridiculous. I think it's going to start eating away a lot of things. And so, but if we're not going to take data and data modeling seriously at this point, then when? Because one of the cruxes I'll get into is that really bad data models are actually going to mean AI gets limited. So we're going to talk about what is a data model, why do you want a data model, data life cycles, and key techniques you can use across the data life cycle. There we go. All right, what's a data model? Well, in my opinion, data modeling is not only Kimball, Data Vault, One Big Table, DBT, PyTorch, just a bunch of tables, whatever else you think it is. There's a lot more to it. Fine, so this is actually from a 1978 book called Data and Reality. It's written by William Kent. I think this is still the best book on data ever written. It's also really old, and it's really expensive. But if you can get a copy, you should get it. I'll let you read what he thinks data modeling is. And nod when you're done so I can know when to move on. Okay, great. Right, but this is, okay, so you're representing information for computers. Now, understand the context in the time that this came out. Computers are still new, right, or new-ish. And you're trying to figure out, okay, so we're going to represent data in a computer system. What exactly does this mean, right? Back then, this is a revolutionary idea, but the notion still holds. Here's Steve Hoberman. Who's heard of this Steve Hoberman, by the way? Like one of the legendary original data modelers. This is what he thinks data modeling is. So notice what this definition and this definition don't say. It doesn't say it's this stuff, right? It says it's a way of describing reality and processing information for, different use cases. Steve says it's a wayfinding tool, right? I tend to agree with this. Here's my working definition for my new book on data modeling, which will be out next year. So a data model organizes and standardizes data to facilitate believable and useful information and knowledge for humans and machines, right? We'll talk about the humans and machines part later, but notice I didn't say correct, right? And I got the believable and useful from Bill Inman, if you know who he is. He created the data warehouse, which is why all of you are here. But I asked him one day, what's your true north? And he said, well, I've always felt that I need to create believable and useful information that creates value, right? That's it. That's the only thing he cared about and still cares about. So I figured that's good enough for him, good enough for me, and that's the definition of data modeling as far as I'm concerned. So the data modeling flow, typically you start with a conceptual model, and you go to a logical model to, a sort of intermediate step, and then you implement it at a physical level. But we'll talk about this. Actually, all too often though, nowadays, we actually we start here and end here, right? So I want to caveat that because this will become important later. So why model data? Before I get into that, let me tell you about the current state of data modeling. This will hopefully answer your question about why I think it's dead or on life support. It's in a coma. I'll shut up. All right, so this is Hieronymus Bosch. Oh, the two screens kind of trips me out. So this is what's known as a triptych, right? So back in the day, people would paint 3 sections describing 3 scenes: Genesis, the Garden of Earthly Delights, and Hell. This is Hieronymus Bosch's The Garden of Earthly Delights, in case you're wondering. I view this very much as a state of data modeling. We sort of started here. We had a brief moment when we were here, and now this is where we are. It's fire and brimstone all the way down, and that's the state of affairs. So it's not dead but it's spiritually dead. So what happened? I'm not going to swear. We're professionals here. So I have a few ideas. The cult of Agile. Who does Agile at their company? Who does Agile? Right? So Agile started. Who's read the Agile Manifesto? Let me ask you that too. Okay, who practices that when they do Agile? So Agile Manifesto was focused on software engineering, not data, right? It wasn't about delivering data. It's about delivering, the continuous delivery of software. That's kind of where a lot of this started. But what this ends up being is like sprints, right? 2-week chunks. You got to work in 2-week segments. Get your data out. And what this means is, I often view data as like a thinking person's sport, where you have to think about what you're doing, right? But if you're delivering features in 2-week chunks, there's a bit of a dichotomy here, especially when we get into conceptual modeling, which we'll talk about. And again, I think that there's a place for, and I'm going to get into this. Agile is it is how the world works, and we can bridge these 2 gaps and continuous deliver data products. But I feel like when you're talking about acts like conceptual model, it doesn't fit neatly into these 2-week buckets that you're trying to ship products with, right? I think once you have physical data models, then the continuous delivery of data models makes a lot of sense, which we'll talk more about. But in general, on the spectrum of fast and formal, fast won, right? So I come from America. We don't do things slowly there. We just like move really fast and break everything in our path. That's how we do it. It's a feature and a bug. I also think the rise of big data ushered in a lot of practices which are necessary, right? And it introduced a lot of new ways of dealing with data. But what I'll talk about in a bit is that we also see sort of cargo cult data modeling, where now practices that were once adopted for large companies like Google and Yahoo through MapReduce are now, we use it on our 1 gig data sets, one big table and all this stuff. Data exploded, new tools, formats, and we also moved beyond the world of rows and columns, right? There's all kinds of data now. A lot of attention on data means every company's trying to jump into it, for good or for bad. And then there's a dev and data divide, which I describe as this. So on the left, you have dev teams. And who does this resonate with anybody? I can see a lot of unhealthy laughter. Right, so this is typically the setup at most companies, right? Is that developers are over here shipping features, data teams are over here trying to do analytics and now data science. And they're working with data sets that, usually are produced up here and then you have to consume down here. And do you ever feel like your data sets that you get from dev teams are awesome and they're just amazing to work with? No, I didn't think so. So yeah, shit flows downhill. That's how it goes. But this is a reality, right? And so you can only get data good up here. By the time it gets here, you're hopeless. At best, you're like gluing and duct taping it together, and you're putting a blow dryer on it so it doesn't. But it's bad. So one thing we'll talk about is closing this divide. And the trends aren't looking good for data modeling. So to your question, sir, about data modeling, this is a Google Trends, and I just put it in term data modeling around the world. It was popular. No, it's not. You're all data people here. You can look at it. We look at relational and dimensional data modeling, 2 popular techniques. Same thing, life support. I mean, if you were at a hospital and you were the doctor in charge of this patient, you would be very scared, and that patient would be in a coma, not too scared because they don't know what's going on. This is what happened. And again, all too often right now, we start at the physical and end at the physical. We'll talk about why that is, but have people seen this as well, right? Where you're so caught up in like, oh, I need to answer this question, I need to build this new table, I need to do this or that, and you lose sight of what the meaning of the overall data is and how it translates, right? This is a hugely important thing. We're doing on time here. Cool. And so, one thing I want to impress on you was a lack of a crappy data model is still a data model. Or lack of models of models is a crappy one, right? So, but this is what I see in my observation. I talk to thousands of companies at this point, and universally, I would say that because we're more ad hoc and focused on the physical stuff, we have a lot of data models now, right? Again, because we're just trying to represent reality of our business, right? But each time you make a table, each time you answer a query, you're trying to answer some little aspect of it. But you're starting to lose sight of the overall picture here. And then when people try and, everyone wants to do self-serve, or analytics or make data products or something like that. And how is this possible when you have so many different variations of the truth floating around your business, right? It's really, really difficult. So crappy data models are everywhere right now. Examples of the problems that result from this. It's not uncommon to see data teams that have like 1,000 plus DBT models floating around. Who uses DBT and anyone uses DBT here? Great company. I mean, I do work with them. I don't blame the tool. I actually blame the fact that data modeling has sort of died out and we don't know what we're doing with these awesome tools. But especially with DBT, what this means is you have 1,000 models, that's often 1,000 views or 1,000 separate tables or more. I did an interview with Tristan Handy, the CEO of DBT, and he said there was one company that had like 39,000 DBT models. right? If that was a number of your children, that would be really hard to keep track of, but that's where we are today. Another big one that I see is ad hoc reactive, what I called query-driven modeling. So I blurted this out on, I was on Seattle Data Guy's show one time. I don't know if you know who he is, but he's, I don't know, good data engineering influencer on YouTube, and we were talking about data modeling, and I was like, yeah, it's interesting, like query-driven modeling seems to be sort of the de facto way we do stuff now, and what that manifests itself as is, I am going to ask you a question, and you're going to get me an answer. I'm going to ask you another question, and you're going to get me a different answer. And pretty soon what you have is you have a bunch of random SQL files laying around to answer different questions, or notebooks. And this is, in a lot of cases, how data is modeled now. It's just very reactive, right? There's no coherence. Has anyone seen this? Yeah? Everyone's like, yeah. WTF, does the data mean? Question mark. This is a common question. Who's been asked this question or has seen this question being asked in their business? Everyone? Okay, great. Yeah, so that's the reality. Nobody understands what the data means because there's no coherent sense of data anymore. Lots of reinventing of the wheel. I see a lot of data modeling approaches coming out that I think are just rehashes of the same old thing. Nico's nodding in agreement, and you as well. So it's like we failed to understand the lessons of the past, and now we're trying to reinvent everything. I'm not going to name names because I'm a nice guy, but if you just went back and looked at the classic techniques, you would understand what I'm talking about. And what this means is a lot of wasted energy, a ton of wasted energy on data modeling that we don't need to spend. One of the biggest sins that I see, one of the biggest examples of problems with data modeling is data hoarding and sprawl, right? This sort of goes back to the point number one with 1,000+ DBT models. Again, I'm not going to blame the tool. I'm going to blame the fact that we don't understand how to come up with a comprehensive view of data, and here we are. Infinite number of views, tables, et cetera. I mean, it's not uncommon to find companies that have potentially hundreds of thousands of these things laying around in their systems. And how will you ever make sense of this? If you wanted to migrate your data warehouse, for example, how would that work, right? Actually, ADE does a pretty good job at doing that. So, But this is gnarly work. This is very difficult, and it's hard for anyone. And plus, people leave jobs, and then that. I was talking to somebody yesterday actually, and they said that you have technical debt, or what was it? It was I can't remember how they described it. Anyway, when a person leaves, really, that's one of the biggest vulnerabilities too. Is you have most of your vulnerabilities are tied up in people. If they leave jobs. Have fun figuring out what they did. I'll give you actually an extreme example of this. I have a few minutes here. I had a client once. They had a DB2 mainframe from the 80s that they were running their multi-billion-dollar company on for some reason. We'll get into that in a second. And then this guy had written the code since the 80s, and he didn't document anything. He's the only one that knew how the system worked. And he'd always show up to stand up. And then a few days he didn't show up to stand up. And a week later, they had to call his house, and then he passed away in the meantime, which is horrible. Horrible, horrible, horrible. And then the system died. And that was really expensive. It took, I think, 3 weeks for that to recover. They had to bring in a SWAT team of people who actually understood this stuff and barely got it back up and running. But for every hour that system was down, they lost 24 hours in productivity. So the amount of catch-up you would have to do it's enormous. They eventually caught up, but the whole team lost their job. The CIO or whatever, he was out immediately. So that happens. So anyway, hoarding, data hoarding. This is a data engineer. He's about 20 years old. And so this is his data stack and all the views and tables that he's accumulated in the 3 weeks he's been on the job. So if you can empathize with this picture, I'm very sorry, but you can talk to him maybe. But you have to dig under the garbage to find him. But that's how it is. We don't, especially this is like data lakes for sure. Like this was like, I don't want to get rid of this phone because I might need that to call my lamp over there or something. So anyway, this is the reality of most data teams. So again, why model your data? You want to facilitate information, knowledge, and wisdom. You want to invest, in things that matter to you, not technical data and organizational debt. A solid data model improves, understanding, performance, and communication across your organization. Finally, and I'm going to go on a limb and say this, I think ignoring data modeling is professional malpractice. Like if you're ignoring this, I don't think you should work in data. So there. If you want to challenge me on this, you can go ahead. The data lifecycle. So this is one thing we're going to talk about real quick. So I need to talk real quick because I'm almost out of time. We create data, we process it and store it, we use it, archive and delete. And notice that processing and storing is an interesting one, and creation, where this is actually, we'll talk about this in a bit, but this is actually many feedback loops on itself. And this is one of the hearts of what I want to talk about, is that we can create, process, and store and use data. Eventually, this is where it goes to die, unless you hoard it, which is also where it goes to die. But the data's life cycles are fractal, right? I'll get more of what this means in a bit. Who's familiar with how fractals work? Okay, I'll quickly describe to you. Okay, so this is also, if you keep zooming in, it keeps repeating itself, basically, right? It's a geometric shape that has an infinite representation, right? This is kind of how life cycles in data work, actually, right? And so here's, from my book, The Data Engineering Life Cycle, where we talk about how data is generated from source systems, ingested, transformed, served, and stored, and for various use cases with its own undercurrents, right? If you've read my book, you can, you've seen this. If you haven't read my book, you should go buy it because it's pretty cool. But that's a life cycle, right? Here's another life cycle. This is they applied AI out of Munich, their machine learning life cycle, right? So this is interesting because much of this is data engineering life cycle, but then you have models and deployment, right? Who works in machine learning, by the way, here? Anybody? One person? Okay. So if you did work in machine learning, this is basically the steps from here to here is the life cycle you're dealing with, right? So you're probably getting data from a data engineer, training models, deploying them, and there's a feedback loop, right? It's very fractal in the sense. It goes back to data engineering, and sometimes it'll go back to the source systems as well, quite often, right? And so that's what I mean. It just isn't, it's not a one-way street. Back in the day, this is how it would work, where it'd be like here, one way, right? With traditional data warehousing was like this. Data warehousing started because people were querying transactional systems and pegging them back in the 80s, and that's a really bad idea because those databases, so you so much as look or breathe at them, they'll just stop. But querying them is that's a death sentence for these databases. So Bill Inman came up, he had the idea of whoa, what if we just have a separate place where you can query your data for analytics? It was but at the time that was revolutionary. But IT departments owned that at the time, right? We didn't have the notion of data products to data-powered applications, right? So the world did really move in a one-way street. That is no longer the case. Data moves in all kinds of directions. As I said, there's feedback loops. Data is no longer one way. We have interactions between machines and humans, and this means feedback loops through the data lifecycle, all over the place. Who uses Uber as an example? The Uber app. This is a classic example of an app that has feedback loops upon feedback loops, right? It is probably one of the biggest data-powered apps in the world, period. But it's not a data warehouse, but it accumulates so much data, right? So there's an app, there's machine learning that'll recommend drivers, routes to you, all this other stuff. People do analytics on it that feeds, has a feedback loop to machine learning, which has a feedback loop to the application, and on and on and on and on. Key techniques. So again, data model organizes and standardizes data to facilitate believable and useful information and knowledge for humans and machines. Why did I mention machines? That's interesting. You'd think I'm just talking about people. Well, if you go back to this case, where are humans in the loop typically? Only here, actually, with analytics. For the most part, we've always been making systems that produce data for machines, computers, and now machine learning models. Right, so it's important to understand who and what are consuming data. Machines are often the transactional processing and machine learning. Right, humans code this stuff, but they're not the ones consuming the data typically. It operates at too much of a scale for humans. Right, that's why we invented computers in the first place, to scale what humans cannot do. Analytics is actually where humans consume data. That's where you're trying to make judgments, right? But this is an important distinction, I think, because all too often, especially in the modern data stack or the data warehousing world, we're focused on this, last part. But you need to remember the first point. So some key techniques: conceptual logical data model patterns, transactional techniques, analytical techniques, machine learning, and then finally what I call mixed model arts, MMA. So yeah, because I like MMA. Who likes MMA, by the way? Anyone? 3 people? Okay. I thought it was like Viking culture or something. So data model patterns. I'm sure Juha's going to be, he's like nodding like, yeah, I like that. I do too. So who's heard of data model patterns before? Right, so I'm going to quickly describe what these are and I'll give you an example. So who lives in a house or an apartment? Okay, so when that was built, do you think somebody just said, I'm just going to start building closets, and at some point I'll get around to designing a house, right? But that's actually how we approach data modeling right now. Like, we're really good closet and cabinet makers, but the overall architecture of a house and the overall blueprint of a house is still sort of mystifying. Conceptual and logical data models they're basically cheat codes, right? These are the blueprints that you can use to build to get a head start on your data model. I think by most estimations, you get probably 50 to 75% of the way there. The other bit is just stuff that's specific to your organization. It speeds up your data modeling work, and again, it provides an overarching data model across your data lifecycle, right? This is the common vocabulary that you'll use with business stakeholders, analysts, data scientists, software engineers. But who feels that they have this in their business right now? Who feels that your data model really represents the reality of your business and that everybody, all stakeholders, well, you work at a company that does data modeling, Dork. Who feels like their data model would be easily understandable by anybody in the organization? You. It's awesome. But what I've been realizing is the conceptual data model is the key actually to, I think, answering a lot of the questions that we would have about what does the data mean, right? This is a lost art, though, like I said. Barely any of you knew about it. Let me explain what it is. So this is an example of the classic party and role model. I'll let you stare at that if you can see it. I'm sorry if you can't. But this, most organizations, they have this idea of maybe people that work there. They might have a customer. They might have the idea of organizations that they, either internally or externally they deal with. And this is an example of a pattern, right? It's generic. You can describe a lot of things with this. You can describe relationships between people who buy and sell things. You can describe relationships between employees and employer and so forth. But this gives you an overarching mental model to think about, okay, if I have relationships, how would I describe them, right? Instead of you having to sit there and figure out, okay, so, gosh, I work at a company and we sell stuff to people and everyone goes through these mental gymnastics. When the answers have been around, this book came out, 2002 or something like that. But anyway, so I'd urge people to look at these patterns. There's a couple books here. The data model, there's actually 4 books here. 3 of them are the data model resource books written by Len Silverson. It's 2,000 pages in total. So just spend a weekend, go through it. But a lot of them still hold, I think. And I think these are probably due for a revision to maybe take into account some of the more digital ways of running a business. But the idea of a retailer still is very valid, the way he describes it. I think 99% of it is. The way you would run a bank or the way you would run a manufacturing company, the models or the patterns that he describes are still extremely relevant and useful. It'll get you a lot of the way there. The Nimble Elephant is another really good book by John Giles, who is out of Australia. He's the closest thing I've seen to Yoda in our industry. He lives in the outback, and when you talk to him, he just is brilliant. He's insanely smart. He wrote a book about the agile delivery of data models using a pattern-based approach, right? So, we're Agile Data Summit, so we Agile Data Engine Summit. So we, and Agile is the way of the world now. What I was saying earlier about the cult of Agile needs to be reconciled with the fact that this is the way the world is, and there's a lot of benefits to Agile if you can think about continuously delivering, right? And so the Agile delivery of data models is about how would you use patterns to basically speed up your delivery of data models and the maintenance of data models. So I'd urge you to read these. But as an example, I think, I'm going to totally butcher the numbers, but I think he was given some crazy short amount of time to come up with a data model for an organization. And I think he came up with it in about, I don't know, it was like less than a day or something like that, I think. It was nuts. And so he shocked everybody and delivered a lot of value. That exercise normally would have taken, without patterns, it would have taken you probably, 3 months. So, useful. Transactional processing. Some interesting data modeling things you can consider here is most data starts at the transactional step, right? Data doesn't typically start in a data warehouse. It comes from somewhere. That's the whole point of a data warehouse. It takes transactional data and allows you to analyze it, right? But applications are often based in transactional data. This is the time, by the way, to get your data model right, because this is, especially when you're starting a company or you're interfacing with customers, that's usually through an application, right? So again, going back to the conceptual model, that gives you the blueprint to build your data model, right? If you are working as a software developer, think of the poor analysts in data science who will use this data. And then consider the feedback loops, because the world, again, of like unidirectional data flows is gone, right? Things like reverse ETL, the fact that, applications are using machine learning, is kind of a core thing. And then also the fact that data for applications, it's not just rows and columns data anymore, right? You have images, audio, text, video, and probably more. An interesting side note, too, when Bill Inman came up with the data warehouse, he got really bored of it really quickly and moved on. Why? What accounts for like most of the data in a company? Is it the tabular data, the stuff you have in your database? Or is it all the emails, all the text documents that people write? Right, he realized very quickly that most of the data you have actually is not the stuff that's in your database. It's all the files that exist outside of it, right? And so how would you combine these two together? So he came up with that back in the 90s, I think. He called it textual ETL. And now, fast forward to today, it's like, AI can do a lot of this stuff. And, I think we're at an interesting point in time where you're going to see a lot of unstructured data use cases take front and center with data engineers. Normalization. So who's heard of like normal forms and normalization? A lot of people? Great. How often do you do this? Never? Okay, you should. You should also floss your teeth and live a good life. But why would you want to do this? Well, it's not because you want to put a lot of extra work in yourself. You want to remove redundancies and side effects with your data. That's what normalization does. It's literally set theory and first order predicate logic. That's how you would get unique elements. And who has duplicates in their data? Question mark. Duplicates, that kind of stuff. Yeah, this would help you avoid that. So, and the thing is, you can apply this to tabular data, the rows and columns, which is what Ted Codd was trying to describe with the relational data model, but also semi-structured data, right? And the same exercise applies. You're just taking entities and relationships and then trying to figure out what's the unique set that does not have other side effects and dependencies. That's all you're doing. I'd urge you to do this as a step, because I'll get into this in a second why. But before that, you should read this fantastic paper called A Relational Model of Data for Large Shared Data Banks in 1970. This was written. This actually outlines the whole relational model that we use today. And it's riveting. You should totally read it. But you should read it. You're a professional. Remember I said about malpractice? Read the papers. This is a classic. All right, analytics, fun times. Analytics is used for human decision making, plain and simple. I could make an argument that probably, large language models will be doing this soon, but for now, humans do this. You're often using transactional data for aggregation, summarizations, et cetera, et cetera. Source data is often a mess, as we talked about. So how would you not make it a mess? Well, you would probably want to find a way to normalize the data. And even if you're getting crappy data, do your best to try and normalize it. Because if you're going to do something like Kimball star schema, right? The whole notion of that is denormalization, which the prerequisite of that is normalization. You don't just jump straight into it, right? I think there's a lot of bad practices when it comes to Kimball. This is one of them. And the reason you'd want to do this kind of stuff and denormalize is because you want to improve read and scan performance, right? A lot of joins in column or databases especially, it sucks. It doesn't work. So it works, it's just really slow. And when you get to petabytes, or bigger, it'll break, right? So that's why you want to get into things like denormalization. And then at some point, one big table, but again, you want to make sure like the rows are unique. You don't want to have petabytes of data where you're gonna have to do a full scan and like half the stuff is a duplicate. That's an incredibly expensive operation. All too often though, right now, especially with the modern data stack, we jump into one big table, right? Or just a bunch of tables, just a bunch of models. So again, normalization. Yeah, read the paper, it's good. All right, machine learning. Not too many people do machine learning, so I'm not going to tell you. This isn't going to be a course on machine learning because that would take forever. But you want to use machine learning when you want to scale past what people can do. Computer vision is a really good example, right? If we had like 1 million images and all of us had to sort through them and classify objects in them, how long do you think that would take this room? Right? For a computer, it would take seconds to do that. That's the whole point. Large language models, right? That sucked up the entire internet, and now you can basically ask questions. They'll give you dubious answers, but they'll give you something like an answer. Machine learning can be used with any type of data, but I've often found the hardest type of data you're going to work with is structured data, rows and columns. So by comparison, unstructured data is fairly easy. We're talking about images, video, text, and why is that? We'll talk about this in a second. But yeah. It's because what you're having to do feature engineering on structured data, right? There are some attempts, I would say, that people back in the day when deep learning got popular, they tried to throw deep learning at unstructured data sets. There's some utility to it. The advantage of using deep learning is that you don't have to do feature engineering. But the problem is there's an overfitting problem, and it's a lot of interesting mathematical dependencies. I can talk to you after about this. And so the most popular algorithm right now is still XGBoost, which came out about 10 years ago, right? If you want to use classification or regression, you're going to be doing feature engineering. And for a lot of reasons, structured data is actually incredibly difficult for machine learning. It just is. Talk to me afterward, preferably over beer. I can tell you all about it. Deep learning is actually really easy to do, to handle unstructured data. Because you're simply, for an image, for example, right? You're taking an image, which is certain number of pixels, you unwind it, right, into a single vector, and then you throw it into a deep learning algorithm, and it outputs stuff. That's precisely what just happened with large language models, right? Took a corpus of text, turned it into embeddings, textual embeddings. You have an encoder and decoder mechanism, and then through some black magic, which we're still trying to figure out, you can get inputs and outputs for generative AI, which is pretty cool. Google originally developed that actually as a translation app, right? So I want to put in a language, I want to get another language. Finnish, I am hopeless at trying to understand that, so I would use that app, right? But that's an example where deep learning is effective. It's unreasonably effective. The thing you got to remember with machine learning is every input is a number, right? Everything you do, text needs to be converted to a number. Everything is a number. And so it's basically just a matrix. Who studied linear algebra in school? I think a few people. Right, so that means it's a matrix. That's literally what you're trying to do at the end of the day. That's all you're doing. Just you have rows and columns of numbers. And that's the magic of machine learning. Mixed model arts. I'm coming up in time here, but I'm a big fan of Bruce Lee. I consider him to be the originator of mixed martial arts through Jeet Kune Do, which he came back with in the 70s. But I like this quote here. Use only that which works and take it from any place you can find it. Right, so one of the notions is, I went through, the data lifecycle, some various, glossed over a lot of techniques. But at the end of the day, you have to know across the lifecycle what techniques to use and the trade-offs of using them. I think all too often with data modeling, we're very fixated on our slice of the world. And we fail to recognize the upstream and downstream modeling techniques that we can use, and the overarching conceptual model that should govern that entire domain, right? So, and the notion of my new book is basically this, what I call mixed model arts, which is there are a lot of techniques out there you can use. Just understand the trade-offs. I don't really care what you use. I literally don't. But you should know the trade-offs of all the techniques and know what to apply. It's very much like mixed martial arts, where, if you're in a mixed martial arts match, you might go to the ground and you need to know techniques there. If you're standing up, you should know techniques that are effective there based on the situation. But you don't want to be the, classically the boxer, that's all you know. Because if you're up against a wrestler, not gonna have a good day. Sorry. So that's the notion of the new book. So anyway, data modeling, I think we're at a critical time in our industry. If we're not gonna get it right now, then I don't know when we're gonna do it. Data modeling is key to making data and AI work. And yeah, let's bring back data modeling. So this is how you can get a hold of me on LinkedIn, if you'd like to do that. If you'd like to ignore me on LinkedIn, you can do that.
Alrighty, Joe.
Well, hold on. Well, and then, shameless plug. There's a new data engineering course I'm working on with deep learning AI. So if you're interested in getting announcements on that, there you go.